All right. So I tried to keep my thoughts as organized as I can here, but testing is a bit of a grab bag topic in terms of there's stuff to talk about in terms of kind of working with existing tests and how to handle test flaky failures that come up. There's stuff to talk about in terms of figuring out how to write new tests and figuring out kind of which kind of base class is right for the type of test that you want to write. There's a lot of gaps in our testing framework. There's stuff to say about our testing suite in general and the tools for working with it. So a lot of different kind of grab bag of topics. And I'm kind of hoping too that I know we have a lot of other committers kind of in the room now. So hopefully this can be more of kind of a conversation that just is guided a bit by this agenda. So hopefully we can keep it kind of informal in that sense. The first thing I wanted to touch on a little bit is working with existing tests. So we'll start with that. I have a couple commands here that are really just how you interact with the test framework in a mechanical sense, how you actually run the tests on the command line. All of these are Gradle commands, and really the only one worth memorizing or paying really any attention to is this Gradle help test, which I think I've mentioned in one of the other workshops. I can pull up my terminal here. Let's see if I can make that big enough. So if you run this, you're going to get a lot of really helpful output in terms of the different settings that the test task in Gradle takes, different kind of ways you might want to run the tests to achieve certain ends, different ways to kind of filter on the tests that get run. So hopefully this will finish in a second here and we can kind of just scroll through that. But in general, all of the stuff that you're going to want to know about kind of mechanically running tests, like how to actually execute a test. Oh, Eric bumped out to the waiting room, dang. All the stuff you're going to want to know mechanically about how to run a test is in here. You can filter on particular test names, and there's kind of wildcard matching that supports. You can run certain kind of groups of tests. We have certain filters set up to identify which tests are nightly because they're a little slower, which tests are awaits fixed because they're flaky and have issues. We have tests that are called bad apple tests, which are particularly flaky. So you can, there's a lot of ways to identify subsets of tests that you want to run. And this test output really kind of saves you. You really shouldn't memorize any of this stuff. It's all pretty readily available. The only other two or three properties that I'll mention here is that there's a property called tests.seed, which the Solr test framework uses randomization pretty heavily to just exercise a lot more conditions than it would be feasible to write test cases for. And so providing a seed kind of sets up the random object that gets used to make a lot of these choices. So if you want to make your test runs more deterministic, or if you want to try to reproduce a failure you saw with a particular seed, you can kind of specify that with this property here. And something that you would use maybe even in tandem with that is this tests.iters property, which lets you run the tests kind of a multiple number of times. So you might hit a flaky failure and you might want to run with the seed that you saw that failure on, but you might want to run the test 200 times in case the failure is also kind of timing dependent. So these are things that are really helpful either when you've written a new test or when you're trying to reproduce kind of a flaky issue. So that's kind of interacting with the Gradle test task itself. Now kind of a word on what these tests actually looks like. So the Solr testing framework is really heavily randomized, like I said, and a lot of times as you look at a test, you'll see this explicitly. You'll see some code kind of access a random kind of an instance and use that to say, change the type of a field that's indexing, or change the number of documents that gets indexed, or how frequently a commit happens, or something like that. But there's also a lot of implicit randomization that happens. The time zone, the locale that test JVMs run in changes based on randomization. Even when you're doing something like creating a Solr core, a lot of times the config set that gets used for that has these variables that get kind of substituted in with random values. So even if you don't see kind of explicit randomization in your test, there's probably a lot going on under the hood to exercise these different conditions. And that's great because it gives us a lot more test coverage than we could feasibly write individual tests for. But it also kind of sucks because it means that tests are continually failing, even if people have really done their due diligence to make sure that they are as solid as they can be. So it's really kind of double-edged in that way. The tests in the Solr project are use JUnit. They're based on JUnit. They integrate with IDEs like pretty much any other Java project that you've worked with. There's nothing too unusual there. The test suite in Solr has over 1,300 test classes, and there's no easy way to tell how many test cases each of those has without going through them. So you can imagine that there are really just tons of tests that get run. And the majority of these tests are what I would at least call integration tests, meaning that they stand up an entire Solr core, or they stand up an entire Solr node, or they stand up an entire Solr cloud cluster complete with Zookeeper, and they interact with functionality through APIs. There are very few unit tests in Solr's test suite. And kind of the combination of these two things, the number of tests we have and the fact that they're pretty heavy integration tests, mean that our test suite is pretty slow to run. If you were to run kind of this Gradle test command here on a pretty beefy machine, it can take 20-25 minutes, and that's like a quick run. But on my personal laptop, for instance, it'll take 45-50 minutes, close to an hour to run, which is a really slow time to get feedback if you're trying to figure out whether something you wrote is good or bad or somewhere in between. So it's definitely not I have a lot of complaints about the Solr tests, but so one thing that you'll run into, particularly with the randomization, and because a lot of our tests are integration tests, where they're standing up a full distributed system, and there are timing issues that brings into play, there are complexity things that brings into play, is that as you're running tests, there do tend to be a lot of flaky failures. So even if you're running kind of on a clean checkout, you haven't made any changes, if you run the tests, it wouldn't be surprising at all to get some failures. And this is kind of what a failed Gradle build looks like. Somewhere up above, kind of one of the last snippets that it shoots out is this list of tests that have failed. To get the screenshot, I just kind of made stream expression test fail. So there's only one test failure here. But one thing to pay particular attention to is that it gives you this reproduce with line. And this is always a really important thing to grab if you might want to look into this test failure later, particularly because it contains all of the arguments that the Gradle JVM was running with when this test failed. So a lot of times you'll see, it has particular file encodings here. Sometimes you'll see locale settings or different things. And that's, I think, based on the module that the test lives in. This one is in Solr.j streaming. So these arguments might change. So it's always a good idea to grab it and write it down just in case you lose it. And of course, the test.seed is really important to jot down as well. I can't count the number of times that I've had a test failure, and then I'm not really thinking about it. I just rerun the tests, and then I lose the seed that actually caused this failure. So it's harder to reproduce down the line. So always a great idea to kind of jot this down. Another thing to point out is that there's kind of a text file that includes the output, the standard out for this test. That doesn't usually contain too much useful, but a lot of times it can be helpful. I guess that's a good place to stop. Does anybody have any questions before we get much further?
There's a couple of questions in Slack, but you may get to it. Like, are there expected failures when you run it locally? And we could talk about that. I don't know if you also talk about bad apple.
I don't talk about bad apple, but that's something to get into. I'm going to look at Fusit, and a lot of those are bad apple tests, so I can talk about that.
And then, yeah, so Audrey, I think your answer is coming in a moment.
I'll try to check the chat periodically too, but I've closed Slack just so I don't get other notifications and stuff.
I guess I'll say though too, other than what Jason will pull up here, there are no expected failures. Like in the general sense, the Solr project is not saying we ever want to fix this. So any help we get with fixing any of these edge cases is greatly appreciated. So
Yeah, I would definitely say there's no single test that we would expect to fail like on a new checkout or something. But that said, it's not unusual to see failures because there's just a lot of flakiness. But there's no one thing that you would just see and say, oh, that's expected, I'm going to ignore this. Yeah.
So the one that I get all the time, and hopefully this isn't a tangent, I'll just drop it in Slack. I get that test and I'm not even, I don't really understand it. And sometimes if I rerun, it goes away. Test core container, I sometimes struggle with.
Yeah, I've seen that as well.
So,
so we do have a lot of these flaky failures. And a lot of times it's a really practical question to understand when you get a particular failure. How should you handle this? Should you stop all development and try to find a fix for this? Should you just tell a committer about it? Should you ignore it and rerun the tests and be happy if they pass? And there's no one great answer to these things. When I initially started this slide, I was kind of hoping to put together like a little flow diagram of like tests to check or things to check at each stage, and that would help guide to a kind of an answer of whether a failure can be ignored or whether it should be dug into, whether you should create a JIRA ticket. But the more I dug into that, the more I realized that I just don't think I even know enough to answer that in the general sense. I think it really is kind of a case-by-case thing on how to handle these failures. But there were two trends and two questions that I think are really important to answer that can kind of guide how you handle individual failures you might run into. The first question is the test failure repeatable? So we talked, I think just on the previous slide about this reproduce with line. If you grab that and you run that again and you get the failure again, and you can kind of continually reproduce that, that's a great thing to create a JIRA ticket for if this happens on main or some other kind of already committed code. Because reproducible test failures are, they're the exception. A lot of times there's timing behavior that comes into it. A lot of times it's influenced by other tests that are either running at the same time or have run previously in the same JVM. If you get a repeatable test failure, that's, you're 3/4 of the way towards fixing it in terms of how these things typically go. If you get a repeatable test failure, there's a couple things you can do. The best thing you can do is to try to trim down the scope of the test to make debugging easier. If the test stands up a 2-shard collection, can you reproduce the bug with only 1 shard? If it's standing up a 3-node cluster, can you reproduce with 2 nodes or only 1 node? Can you kind of cut down on the queries or the maybe intermediate steps that aren't strictly required to actually reproduce this test failure? And this is all kind of general software engineering debugging skills at this point. One thing that is a little more specific to Solr is how you might figure out whether something is repeatable. You can just rerun that reproduce with line that Gradle spits out. But there's other tricks that you can do to try to get the test to reproduce if that doesn't work. You can just run that as is. You can rerun the whole test suite because as I mentioned before, a lot of times these failures are timing dependent, and that timing is influenced by other tests that are running at the same time. So a lot of times some things will fail when they're run as part of a suite or when Gradle is doing certain parallelization in terms of how many tests it's running. But it won't fail when you run it individually. So you can try to run it on its own. You can run it as a part of the whole suite. You can run it with different kind of parallelization settings that you can give Gradle in terms of the number of test workers that it uses and things. Yeah, so those are all things that you can do to try to judge whether you can even reproduce the failure. And based on whether you can or not, that's going to influence kind of where you go next. The second question, and this is one that I think we have much more ammo to actually kind of deal with, is this a new failure? Obviously, if a failure is new, if it's not seen anywhere else, then it's more likely to be related to code that you've changed or edited. versus a failure that maybe has been failing on master on and off for weeks or even months. And the main tool that I'd recommend for looking at this is a website called fusit.org. Can I copy this link here? Yeah. Okay, you guys are looking at kind of a an Excel looking table here.
Yep, we got it.
Okay, cool. So this is a website that's run by a committer named Chris Hostetter. And what this website does is it aggregates all of the failure reports and build reports that are put out by different Jenkins servers. Jenkins, if you're not familiar, is a CI server that is used to run tests nightly or on commit or kind of on a regular basis. And as you can see here, there are a lot of tests that fail pretty regularly. This one you can kind of throw out because you can see it doesn't get run all that often. It's probably only failing in some particular circumstance. But I mean, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 tests that fail at least 1% of the time, which when you put those together means that 1 in every 10 builds will likely fail, right? Like that's I don't think that's totally exact statistics, but it's not good. So this again just kind of emphasizes how often you'll see these failures. Audrey, you had a question?
Yeah. How do you know when these failures are not a big deal, or like any failure is a big deal, I guess, but how do you know when these things, when you break Solr, if we always have a low level of failures on our tests?
So the answer, I mean, I think the obvious answer is that you don't know. When you have tests failing all the time, it's really hard to tell whether you've broken something or not.
Right.
One thing, I hope this works. One thing that I find really helpful is if I have a certain test failure, you can go in here and see kind of a historic trend. And this is really kind of cool.
Yeah.
You see, well, this test was totally fine, no failures at all until, what was that, mid-November? It looks like there was a big jump towards the end of November. Now the granularity here isn't awesome. It's only every week, which I guess makes sense since we're kind of aggregating nightly test runs, right? But so it doesn't identify a particular commit, but in hindsight, it can tell us that like something here broke between say mid-November and the end of the month.
So like if I make a PR with a feature and let's say there's a new test failure that has no recent history in this diagram, would the reviewer check this before allowing me to merge to master, or like what?
Probably
I guess, like,
not.
right. Like
and-
what are the boundary, like how do we use the tests?
I think this stuff here gets used after the fact very
Right.
much, like backward looking, like, boy, yeah, that seems to be happening a lot. Is it? Oh, that's interesting. Something about our streaming expression test KNN seems to have changed. And then, there's kind of debugging and digging into it.
Yeah,
Okay.
the-
And then,
The other thing
like-
I'll mention about that, you mentioned a PR. The
Yeah.
PR tests are not all of the tests that run. I
Uh,
don't think they fail on a regular basis. I have not seen a
You're
PR
talking about
test fail. The GitHub Actions tests
Yes.
that run.
Okay.
It's a small subset of all the available tests, but for the most part, those almost always pass unless you screw up something very egregious. And then
Okay.
those blow up correctly.
So,
okay, that's good, because yeah, like how do you know if you are about to take down all of Solr, or like, I guess you wouldn't it's not running, but in a release or something.
So what I do when I'm reviewing a PR, and I think every committer kind of has a different pattern here, and I think the community has kind of gone out of its way to not mandate something because we don't want to kind of make some rule that everybody has to apply across the board because we'd never agree on it. But what I personally do when I'm reviewing a PR is I will pull it down locally and I'll run the tests on it, and I'll run them maybe twice, sometimes only once. It's not the best due diligence, but if there's a test that fails pretty, that if that does trigger any test failures, then I can come to this Fusit and see whether they're new or whether they've been failing at all recently. and that at least catches some things. It's not going to catch everything. So then I might go and merge the PR. And then I might leave it on main for a week or two and then see if any new tests start failing in Fusit that seem related to that functionality. And that's why there's generally this gap between when something lands on main and when it lands on a more stable branch like branch 9x.
Okay, and then for the releases that Solr puts out, is there a base level test passing percentage you have to have? Or like, is it just woo, like we're
so my understanding is that people just look to get a passing build once when they're like building the release candidate. They just needed it to pass once, which is unfortunate. I know a lot of times if somebody's working on a release candidate, they'll stop and try to fix some of the worst failures to kind of meet that quality bar, but I don't think there's any hard and fast rule there. Eric, Kevin, do you know anything? Does that sound right to you guys?
For the releases themselves?
Yeah.
So the smoke test release script that runs is a completely different set of tests than what run in the PR. Those catch a lot more failures because it runs a lot more tests. So it's a more stringent process in the release. It does not catch nightly things. It does not catch bad apple tests. So there's a whole bunch of things it doesn't catch. But between the tests that are run nightly, the emails that go to builds@apache.org for Solr, they all give you some indication of things are better than they were. I know I keep an eye on the overall health for the most part of the project, just to making sure that we didn't introduce something bad. So I'll go figure out what that KNN stream thing is pretty soon here. So.
Cool, thank you.
Yep. Thank you. Let's see, where was it? Okay. So yeah, you can come in for a particular test. You can look at kind of this historic trend line, which may help you identify if you just hit a failure locally. If it's not, if it's 0 all throughout here, then this is probably something that you introduced. Similarly, kind of a useful thing. I hope this is going to work. Is this list here are links to the actual Jenkins builds themselves that get run. Now, a lot of these links are going to be broken just because the Jenkins servers that individual committers are running or the ASF are running don't retain builds, necessarily for 7 days, which is kind of the history here. So you might click on this and it might end up being a dead link if you go to get the URL for the Jenkins server. Yeah. But if you try enough of them, you're bound to, man, I can't get the screen sharing controls out of there. Okay. If you try a couple of these, you'll likely find a link to Jenkins, and you can kind of look at the whole logs from the build there. You can look at any other tests that failed in tandem. What's the most recent build number here? 744. Let's try that. And there's also the logs that are zipped up here that are retained on this Fusit website. So even if we've kind of if it's cycled out of the build history on the Jenkins server itself, you still have access to some of the artifacts from that build. Yeah, here we go. Okay, so if you're unfamiliar, this is Jenkins. It's a kind of a continuing integration site, and people have these jobs and they can set them up to run on different kind of triggers, either nightly or when commits trickle into the Solr repo, it might kick off a job on demand. But you can go into any one job and you can look at the console output. Sometimes there are artifacts that are saved in terms of logs and things like that. Here there's kind of, is it Surefire? Is it Failsafe? I forget what actually produces this report, but Jenkins has a plugin to make it viewable and stuff. So you can see which tests failed or passed and how much that changed compared to recent runs. Yeah, I think that's most of what I wanted to say there. Anybody have any questions about fusit.org or how we use that and how we can use these Jenkins builds? Okay, cool. Let's see, can I go back here? So these are the two questions that are kind of most prevalent in my mind when I'm looking at a failure that I'm not sure what to do with. The first is it repeatable? And the second is it new? And Fusit and these Jenkins builds that we have are kind of good tools for answering at least the latter question. And the last thing that I would mention here is, particularly if you have a PR open, if this is something that you're worried might be new, it's always good to just be kind of transparent. Say, hey, I ran into this failure, but couldn't reproduce it or whatever. And then the committer or whoever's reviewing your PR can figure out how they want to deal with that. And it at least gets kind of another head involved in the discussion there. One other thing I wanted to touch on, and this gets a little bit back to the mechanics and the actual kind of Gradle interface for running these tests, is we talked about the test task before, and using tests.iters, which is short for iterations, to kind of run a test a bunch of times. And that can be helpful for fleshing out failures that are flaky, or even on a new test to make sure that, hey, if you've added this new test, let's make sure it's really solid before we commit this, so that it's not going to be one of the flaky things that people shake their fist at later, But the way that the test task works, it reuses JVMs for each iteration that it runs. And so things like static initialization in the test class only occur once. So if there's randomization in there, you might be running your test 100 times, but some of that randomization is only occurring once. So there's kind of an alternate task called the beast task, which has syntax very similar to test. You just use the word beast in your Gradle command instead of test. And this will create a new JVM for each kind of iteration that it runs. So it ends up being much slower, but it covers much more ground if there's kind of static initialization in this test class that you want to be randomized and not to be kind of reused iteration to iteration. Yeah, I think that's everything I wanted to say there. Cool. So that's the last thing I had to say about kind of handling failures that come up. It's definitely not an ideal situation. It's definitely not a perfect situation. And a lot of failures do end up being kind of requiring judgment and being kind of a case-by-case basis in terms of how they get handled. But there are some tools, and hopefully that's helpful for you folks as you run into test failures. The next thing I wanted to talk about was writing Solr tests, but I wanted to pause again for questions there in case there's anything before we move on to kind of adding new tests. Cool, sounds good. So I mentioned earlier that most of the tests in the Solr test suite are integration tests. And I think that is indicative of the philosophy that the Solr community as a whole has. If you're adding new functionality, if you're adding a new feature, I think most people would agree that needs to have some kind of an integration test exercising it. It's hard to really be certain about a feature from unit tests alone. I personally think that unit tests are kind of undervalued in the community. A lot of times you'll see people write integration tests instead of unit tests, even where unit tests would get the job done. And that kind of contributes to the overall slowness and or flakiness, because integration tests tend to be a little more flaky because you're standing up a whole distributed system. In terms of what tests you need to have for a given PR that you're writing, I do think reviewers tend to be somewhat permissive here. If you have some testing, I don't think you're going to get too much flack, though you may. It all depends on your reviewer. But the general attitude that it seems like people have is to not let the perfect get in the way of the good. If you have some tests, if you've shown some good faith in trying to verify the functionality that you're working on, I do feel like there's a relatively kind of permissive attitude on that. There's not much nitpicking that happens in regard to tests that you write. Does that strike you guys as true, Eric, Kevin? Yeah. Okay, that's kind of my sense of things, at least.
Yeah, we don't have any like kind of maybe what Tita asked. There's no like, oh, the build failed because you didn't have code coverage. Right.
Right.
We don't really have any of those kind of more formalized things.
Right. And there's an argument to be said that we should, but it's just hard to require in an open source environment where people are kind of giving their own time to, I don't know, it'd be a hard thing to get adoption for in the community, I think. Not that it would be bad, just that it's hard to get buy-in for, I think. In terms of kind of the priorities here, this is like something that I jotted down that makes sense to me and that I think there's some agreement on. The most important thing for a test is stability in a lot of people's minds, I think. Solr has such a problem with flaky tests that if you're adding a new test and it's flaky, that's one of the few things that I think would get you pushback. If you're adding a test that out of the gate is flaky, people are going to notice that. Kind of second priority, I'd say, is readability, then comes speed, and then comes comprehensiveness. In the Solr community, especially, we talked about randomization being used as a proxy or a replacement, or at least leaned on to supplement kind of comprehensiveness. And so you see that a lot of times where it saves people from writing explicit test cases because they're able to randomize things. And so this is by no means a rule or a law, but this is just the sense that I got looking at some tests in Solr and my experience with them in terms of what people prioritize. So if you were about to go start writing a PR, there's a couple steps you might want to go through. The first is you probably want to investigate what tests are already out there. If you're adding to an existing feature, like say you're adding a new feature to the join query that Solr supports, well, very likely there's already going to be integration tests out there. So you don't need to start from scratch. You can probably just add a new test case or even add to an existing test case. And this is a mistake that gets made even by kind of committers who are used to working in the code base, where we end up with a lot of test classes that are kind of near duplicates of one another, or at least could be combined in theory. So you want to look at what's already out there. And obviously you can kind of, well, let me switch to my terminal here. When you're looking at tests, like we mentioned before, there's over 1,000 of them, so it can be hard to make sure you're seeing everything that might be out there. So a lot of times I'll run a find command. You can look for particular patterns, like a test that has the word test and it has the word join and it ends in Java. So you can run that, and that'll give you a couple places to start. That's relatively primitive, though. A lot of times where you really might find things that are useful is if you go into your IDP and you can do a similar search. So you can look at the classes that contain the word join, and then at least in my IntelliJ, it highlights the ones that are tests for you in a different color. So you can find things that might be a good place for you to add your test onto rather than starting anew. The last thing that you might do to find tests, if you're not finding anything in the terminal, you're not finding anything in IntelliJ, is if you do a git log or to kind of identify commits that have touched this functionality that might have added tests with a name that you didn't anticipate or something like that. A lot of times tests might have a name that you wouldn't have chosen necessarily, but that you could add to if you need to. And so those are the three ways that I look for stuff that's out there. By looking at kind of Git tracking, by looking in the IDE, and by doing kind of primitive string search in the terminal. So if you don't find a test out there that already does something similar to what you're trying to do, then you'll need to create a new one and decide what base class to use. So we'll talk a little bit more about that in a second. But once you decide on that, you can write your test. I put question marks here, but this is really just write your test. And then your PR gets merged, and you need to kind of periodically, it'd be responsible at least to check fusit.org or follow kind of the build emails that get sent out on the mailing list to look for kind of flaky failures that your test might have. To drill in a little bit on the step to deciding what base class to use. Solr has a number of kind of base classes that it uses that kind of stand up an integration test harness at a couple different levels of, let's say, abstraction. One of the lowest test cases is Solr test case J4, which until recently was kind of a class that everything was required to extend. Every test had to extend Solr test case J4. But the harness that this kind of sets up allows you to create and destroy individual cores. And so this is useful for testing out functionality that's specific and isolated within a particular core. So, you know, if you, well, actually join wouldn't be a good idea because usually joins involve two cores, but let's say you were changing something about the prefix query in Solr. You could probably use a base class based on Solr test case J4 because you can just create a single core, you can add documents to it, and then you can run your query. Let's go over here and look at an example. I think cursor paging test. Is my not terminal, is my IntelliJ visible to people? Is it readable? Okay. So cursor paging test extends this Solr test case J4, which is one of Solr's kind of lowest level integration test harnesses. And you can see it kind of doing most of its work here in this before class method and in this after method. The heart of the before class here, we're setting a couple of system properties, but then we're creating a specific core with a particular Solr config and a particular schema. And then this core is automatically cleaned up in an after class that kind of lives in the parent class. So something you see pretty commonly in these Solr test case J4 classes is there will be some at before method that creates a core. In between each test case, you'll delete all the documents, which is what this is doing. Assert U is a helper method that just validates that an update command to Solr went through. And this one in particular is deleting all the documents that match this query, which is all the documents, and then it'll do a commit. So the net effect of this method is to delete all the documents in between tests. And then if you look at an individual test case here, we have a lot more of these assert U commands, which are adding documents and running commits. And then we're testing that certain queries fail in particular ways that we expect. We're looking for particular substrings kind of in the error message that come back. So that's Solr test case J4. Again, that's kind of our lowest level integration test harness. To kind of move a rung up the abstraction ladder, we have Solr Jetty test base, which is our next class. Excuse me. This class runs a single Solr within Jetty using a class called Jetty Solr Runner. And this is useful for tests that need a full Solr node, but that don't need kind of a full multi-node cluster. They don't need to run Solr Cloud. They don't need access to Zookeeper, anything like that. And so a good example of this is, I open it, HTTP2 Solr client test. Okay, so you can see this extends Solr Jetty test base. There's some stuff, but in terms of kind of the harness surrounding the test and the setup, the meat of it is really in this before test method. Oh yikes! where you're kind of setting up a Jetty config to have certain properties. And then you create and start Jetty, which starts Solr. This is kind of the method call that actually starts Solr here. And then you have a Jetty server that you can interact with. Yeah, and then in terms of what individual tests look like, since you've started Jetty, you know what port you're on, you know you're on localhost, so it's easy to kind of create a method to get a Solr client. And then you kind of just use Solr client to make requests to Solr like any other API call to any kind of Solr server. So once you create Solr, it's you're mostly just using SolrJ at that point. So the final step up the abstraction ladder here is Solr Cloud Test Case, which doesn't just run one Solr in Jetty. It can run kind of an arbitrary number of Solrs, and that they're all they're all kind of part of a larger Solr Cloud cluster using an embedded Zookeeper. So these are the test cases that use this. This is kind of our slowest test harness, as far as I know. But it has access to everything that you have access to in a Solr Cloud cluster. So if you want to run kind of admin API commands, if you want to create arbitrary collections, delete arbitrary collections, check raw values in Zookeeper, you can do all of that in Solr Cloud Test Case. And one example we can look at is add replica test. Okay. And here we have a setup cluster method. This gets called once for the whole class. And this is really kind of a builder that you can chain calls onto here. But essentially, this is the code that actually spins up the Solr Cloud cluster used by this test. You start with a call to configure cluster, and you pass in the number of nodes you want. And then you can add various config sets that live in the cluster, or set different cluster properties, or modify the cluster in kind of arbitrary ways. And then it actually gets executed when you call configure. And again, in terms of what a test class actually looks like, we have this harness. It works by, if you go into this configure method, it's instantiating this cluster variable, which is a mini Solr Cloud cluster, I think it's called. But from that object, you can do kind of some convenience things like clearing all the collections between test runs. And there's also convenience methods to say, get a Solr client that's pointed at this particular cluster. And much like tests that use SolrJ test base, you're mostly using SolrJ since you have access to a Solr client. And just interacting with Solr through its APIs and through this SolrJ client.
So this is very much an integration style test.
Yes, yeah.
Like, this is thoroughly over in the integration world.
Right.
Adding the replica. Okay.
I think you could debate whether Solr Test Case J4 is truly an integration test. Mm-hmm. I kind of argue it is, because you're standing up a whole Solr core and you're like indexing documents and it's putting files on disk and all this stuff. But definitely by the time you get to Solr Cloud Test Case, you are running an integration test. Absolutely. And then Solr Jetty test base is probably more in the middle, but I still say anytime you're starting Jetty, this is an integration test, right? Yeah. Okay. So any questions about those base classes or when you'd use them? I haven't checked the chat in a while.
I think you're good.
Cool.
You're good, Jason.
Okay. And this is definitely not to be exhaustive. Each of these classes in particular has a lot of slightly more specialized variants that are kind of extensions of it. Like you'll run into classes called abstract distrib ZK test base or things like that that extend Solr Cloud Test Case. There are various things that extend Jetty test base. So this isn't meant to be exhaustive, but these are kind of the main three base classes that jump out at me. So hopefully it's easy to pick a base class once you know kind of the functionality that you want to test, and then you can write a test. And then of course you want to be usually when you're writing a new test from scratch, I'd kind of advise people to run a lot of test iterations on that locally, or kind of beast iterations depending on how paranoid you are, just to make sure that you catch any flakiness before it gets committed, before you push it up for a PR, rather than thinking you're done, moving on to something else, and then having somebody comment on your Jira ticket that like, hey, this introduced this new failure for me, which is always kind of demoralizing, I feel like. But so that'd be my recommendation. The last thing that I had planned to talk about here is some gaps and improvements that this test suite kind of has proposed or ongoing, or that we're aware of. and this is just a short kind of bulleted list here. So all of our tests, almost all the tests in the Solr checkout are, JUnit based, they're Java code. So we don't have anything that tests the admin UI, which is a big gap. And it's probably one of the reasons that it's so hard to attract contributors to the admin UI, and why we're kind of falling behind web development a little bit there. There's also little to no kind of full artifact testing. We do have a smoke tester, but there's nothing that kind of takes a nightly build of Solr and runs, say, Dockerized testing that uses the Docker image. I know a committer named David Smiley has kind of brought this up as a big gap from time to time. The last thing that the Solr doesn't have, it kind of has some of the building blocks for, but it doesn't have anything organized or standardized, is the idea of kind of a nightly performance testing benchmark. There are a couple things that are available that could produce data for this. There's a project called Solr Bench, which was the outcome of kind of a Google Summer of Code project within the community at a certain point. And this is kind of meant to run pretty full end-to-end performance tests, where you're starting up Solr in a particular configuration, maybe on multiple machines, and kind of running benchmarks on that. We also have a benchmarking module in the Solr repo itself. It's under, let me see if I can just bring it in here. It's under /Solr/benchmark. And it uses a library called JNH to do kind of more targeted micro profiling within kind of a single machine within a single JVM. And this is kind of committed on main in Solr today. So we have kind of various tools to do benchmarking, but we don't have anything that runs these nightly. We don't have anything that kind of tracks performance over time so that we could notice degradations. And this, I mean, it is a problem for us. I've been pinged even very recently kind of on a performance issue that I introduced. So this is all to say that there's a lot of gaps in the testing that Solr has, and there's a lot of room for improvement in the tests that are there. So there's lots of room to contribute and kind of improve the situation there. Cool. That's all I had planned to talk about today. Does anybody have any questions? Anything else related to testing that they wanted to talk about or discuss? That's all I got.
So I'll throw out there's this relatively new in the last year packaging tests from the BATS framework that will actually download the tar.gz and run everything. So much better than it was.
Yeah, my understanding of those tests, and you could correct me if I'm wrong. My understanding was that the goal of those was to test the bin Solr script itself, or are they testing kind of more end-to-end Solr functionality?
It may have been a test bin Solr originally, but it does test modules and a bunch of other stuff that you can only get outside of the build system. So it is
Okay.
It is
Very cool.
testing a couple other edge cases.
Cool.
Security manager being one that's completely different inside the test framework versus outside.
Okay, very cool.
So one of the things I've wanted to try is, I made some token stream filters, and I could not figure out how to test it. It sounds like maybe the answer is just fire up a solo from one of those test cases and hit the analyzer endpoint.
Yeah, so you're talking about a token stream that is kind of exposed at the Solr level?
Yeah, so it's going to be part of an analysis chain.
Yeah, I think that would be one way to test it, right? To add it to an analyzer chain, create a core based on that Solr config.xml and that schema.xml, and then index documents and run queries that would allow you to
Definitely a
test
pattern,
data
right?
tokenized.
That is a pattern, right? That we've got already.
Like testing tokenizers and stuff.
Yeah.
Well, I
I
think that
imagine it is.
the meta is to test a plugin. Like I've got some third-party code. I want my own plugin, whatever. But I want to bring in Solr's test framework. Like, what's the tricks of the trade there, right? Like, Gradle import Solr test framework kind of thing.
Yeah. So the Solr test framework, a lot of the base classes that we talked about, and some of the utilities that lie behind those, like mini Solr Cloud Cluster, are made available in kind of a published artifact called the Solr test framework, which Eric mentioned. And so if you have your own separate Java project, and you want to test something using those, I mean, those are available to you if you add a test dependency on this Solr test framework. I've heard anecdotally that there are problems doing that, but I'm not too familiar with them myself. Maybe somebody else could chime in. But I've worked on projects before that do that and have done it successfully.
And I think one thing I'll say, maybe not an answer to your question, Bill, but we should probably ask more questions on the Solr dev mailing list on how to do things, right? I think that we sometimes try to figure it out ourselves, and it can be very confusing. What should we do? And if you just send an email and someone responds, you're like, oh, okay, that makes total sense.
Yeah, for sure. Particularly with the dev mailing list and questions like that. You know, I wish I'd had experience with token stream testing to answer that, but somebody on the dev list definitely does. You know, the number of eyeballs on that list is pretty large. Getting responses can be hard, but it's definitely the expertise is definitely there to answer it.
And is modern practice to have like a schema.xml associated with your test, or to fire up a minimal core and then hit the configuration endpoint and put in the fields and the field types and crap that you want?
That's something that we've kind of gone back and forth on. There was an effort at some point, I forget who underwent it, to cut down on the number of schemas that we have, in anything that needed to deviate from one or two kind of basic schemas would be done using the configuration endpoint, as you mentioned. But I think that effort is kind of largely petered out because people found that in practice, it was often just simpler and easier to understand if you kind of had your own schema.
I shared my screen. I mean, so this is, in the Solr, whatever, Solr core source test files, right? And so if you look at all these are all examples of different configs being loaded, right? And if I open up good old collection 1, how much I hate you, and I open up this, hopefully I'm right, boom. How many different schemas would you like, right? We have plenty of schemas, including, I appreciate all the bad ones, right? And, here are a whole bunch of files. There's a schema for, kind of all the different things that you might want to do. And this one is built, I think, primarily around that Solr Jetty test base. Like, these are just a single core Solr, right? And you say, what config file, what schema do I want? If there's any sort of supporting files I need, right? And that's wonderful. And so you could just add your own and, just kind of find one that kind of does what you want. And that's a great one. Now, the other place that I see a bunch as well is config sets, right? So at the more integration level of testing, how many config sets would you like, right? We have all sorts of different config sets that do interesting.
Which in practice makes it like totally infeasible to really understand what any of these do and whether you need to create a new one. So I feel like it causes this proliferating thing.
No question, right? Cloud managed, pre-analyzed, you can kind of dig in here. So
yeah, so back to your question, Bill, about do you use schema or do you use the config API? I like to use whatever I'm going to be pushing to production best I can. Right. So if it's going to be a single core schema XML, then do schema XML. If you're going to be doing Solr Cloud with config sets or the config API, put that in your test. They both work.
Anybody else have other questions or things they want to talk about? Cool. Well, thanks for coming, everybody. It's great to see everybody again, and I hope it was helpful for folks, and we'll talk to y'all later.